Okay, welcome to another video on the marathon series. This time the topic is integration by substitution, and we'll start doing questions. Question number one says the diagram shows a curve this. Find and its maximum point m, find the exact value of the x coordinate. So I don't see any other way but to use the product rule. I'm going to say u is x square, v is 1 minus x square to the power half, u dash is 2x, and v dash is half 1 minus x square power minus half into minus 2x. So dy by dx gives me u dash v plus v dash. V dash would be this u. Okay. Then equals to 0. I might run out of space. So either this can equal. Let me just simplify this first. Okay, then let's take that here and try to solve. Okay, there are two things that I could do. I could either take a common and say that either x equals to 0, or I could just take this to the other side and then cross multiply, because I think that would solve the problem. It becomes a relatively longer question then, but I think that's easy to solve because the root multiplied with the root eliminates the root. Okay, so then I can also, I know that one of these values will cancel out, so I'm just going to do that, and I'm going to say that x equals to 2 minus 2x squared. So that's 3x squared equals to 2, and x squared equals to 2 over 3, and x equals to plus minus root 2 over 3. I will just take the positive one since this is on the positive side, and I'm going to say it's just the positive one, and root 2, this should equal root 6 over 3 on my calculator and nothing else. Then it says show by means of a substitution x equals to sine theta that the area of the shaded region between the curve, the x-axis, is given by this. So I need to find this point first so that I can use it as a limit. I'm going to say that either this equals to 0 or that equals to 0. That gives me x as 0 and 1 minus x squared as 0. X squared is 1, x equals to plus minus 1. So x equals to 1 because it's again on the positive side only. Then I'm going to write my expression for part 2, and I'm going to say that part 2 is basically integration from 0 to 1 of the expression x squared root of 1 minus x squared dx. It's very important to write the correct expression, or otherwise it wouldn't change. Then I do my immediate substitutions first. X is sine theta, so I'm going to say that sine theta squared into 1 minus sine theta squared, and dx, to replace dx I'm going to differentiate this, and I'm going to say that dx over d theta is cos theta. So dx becomes cos theta d theta. So then using a substitution, cos theta d theta. So I get sine square theta uh, into root of cos square theta into cos theta d theta. Then I have sine square theta into cos theta into cos theta. So that gives me sine square theta and cos square theta. Now, if I remember my identities correctly, then sine 2x was 2 sine x cos x. which means that sine x cos x on its own should equal sine 2x divided by 2. So for this I can do sine theta cos theta whole square d theta, and say that this becomes sine 2 theta over 2 whole square d theta, and that brings out half sine 2 theta, not half, 1/4 in the denominator, 1/4 sine square 2 theta d theta. Changing the limits, x equals to sine theta, so if x was 0, then sine theta should also be 0. Sine inverse of 0 is 0, so I'm going to put the lower limit as 0, and for sine theta equals to 1, I'm going to say that the first value time it's 1 is at 90 degrees, so that's pi over 2, so I get pi over 2 in the upper limit. Okay, I think that meets all of the requirements. Then it says hence obtain the exact value of a, so I'm going to try to integrate that. I'm going to say that sine squared 2 theta d theta has to be integrated. Now remember that we've done this before, that cos 2x is 1 minus 2 sine squared x, and cos 4x is 1 minus 2 sine squared 2x. So in order to find the integral of sine squared 2 theta, what I'm going to do is I'm going to make sine squared 2x the subject, which means that I can replace sine squared 2 theta with cos 4 theta, 1 minus cos 4 theta over 2 d theta. I've made sine squared 2x the subject from here. After having done that, this becomes 1 over 8. When I pull out the coefficient, this becomes theta minus cos theta's integral is sine 4 theta over 4, and my limits are 0 to pi over 2. So I have 1 over 8 pi over 2 minus sine 4 pi over 2 over 4 minus 0 minus sine 4 times 0 over 4. So 1/8, that gives me 2 pi. Sine of 2 pi is also 0. Yeah, so I think I'm getting the correct answer. All of the other terms are 0, 0, and 0. So pi over 16 is the correct answer. Yes, that is the complete solution to part 3. Moving on to the next question, it says use the substitution 1 minus x square over 1 plus x square whole square as cos 2 theta. Okay, so using the substitution, so I'm going to say that the immediate substitution is 1 minus tan square theta and 1 plus tan square theta whole square dx. Now trying to replace dx, so x equals to tan theta, dx over d theta is sec square theta, so that gives me dx as sec square theta d theta. So sec square theta d theta. Now if I remember my identities correctly, the denominator is 1 plus tan square, which is equals to sec square. So one of these powers cancels out. I am left with 1 over sec square theta minus tan square theta over sec square theta. Okay, so that I need to convert it into cos 2 theta. I think I am sort of getting to that point where I can see that emerging, cos square theta, and if I change tan into sine square theta over cos square theta, and there's a sec square theta in the denominator, which means that it's 1 over cos square, so that comes up in the numerator, and this cancels out with that. and I'm left with cos square theta minus sine square theta, which is essentially cos 2 theta d theta d theta d theta. That is what the question was asking me to prove. Then it says hence find the exact value of this. So I am going to replace, I've done the substitution, I just need to change the limits. I'm going to say that x equals to tan theta. So when x was 0, tan theta was also 0, tan inverse of 0 is again 0, so theta is 0, and x equals to 1, so 1 equals to tan theta, and that gives me theta as tan inverse of 1, which is pi over 4. So 0 to pi over 4 cos 2 theta. Integrating cos 2 theta gives me sine 2 theta over 2 with limits 0 to pi over 4. So sine 2 pi over 4 over 2 minus sine 0 over 2. Sine 2 pi over 4 gives me half. So that is my final answer. And I hope that's correct. Yes, that is indeed correct. Moving on to the next question. Question number 3 says the diagram shows the curve this and its maximum point M. Find the x coordinate of M. This is a question on product rule differentiation basically. So u is sine square 2x. When you differentiate you get the power down, you reduce the power by 1, then you start differentiating inside the bracket. So sine 2x differentiates to cos 2x, and then you also have to multiply by 2 because you have to differentiate the angle. Then cos x is simply minus sine x. So dy by dx is u dash, that's 4 sine 2x cos 2x, v v dash u. I see something as common, I see sine 2x as common, so I am left with 4 cos 2x cos x minus sine x sine 2x. I will try to solve this. It's a 6-mark question, so it's probably going to take me a bit. So sine 2x equals to 0, or 4 cos 2x cos x minus sine x sine 2x equals to 0. For sine 2x to be 0, it could be in any of these quadrants. Sine inverse of 0 is 0. By default I'm in the first quadrant only, so even if I double that I get the first 10 seconds. I'm going to check the first 10 seconds. I'm going to say that 2x equals to 0 and quadrant 2 is 2x equals to pi over 2 minus 0. So sorry, pi minus 0. So I get x as 0 and x as pi over 2. None of those fit my criteria. Why? Because I want somewhere in the middle between 0 and pi over 2. So let's try solving this then. You have I see tan emerging from this setup. You have cos x and then you have cos 2x. So this becomes 4 equals to tan x tan 2x. 4 equals to tan x 2 tan x. So I get 4 equals to 2 tan square x over 1 minus tan square x. That's 4 minus 4 tan square x equals to 2 tan square x. 4 equals to 6 tan square x, and tan square x is 4 over 6, which is 2 over 3. I'm only going to take the positive one. Why? Because it has to be in the first quadrant, 0 to 90. So I'm just going to say that quadrant 1 is basically tan inverse. Let's tan inverse of root 2 over 3. Let's see what that gives us. It gives us 0.685. Yes, that is the correct answer. So x equals to 0.685. Then this question had to be about substitution essentially, but this was a 6-mark part, so it took us longer. Let's look at the second part. It says using the substitution u equals to sine x, find by integration the area of the shaded region. So first I'll set up my integral and say that area is basically the integration from 0 to pi over 2 of this sine square 2x cos x dx. So I will substitute what I see immediately. U equals to sine x. Whatever I see, I'm going to substitute. I don't see anything that is substitutable right now, so I'm going to try to replace this first and say that x equals to sine x. So dx over d u equals to sine x. Therefore du over dx should equal cos x, and dx should equal du over cos x is dx. So cos x and du over cos x. So that helps me cancel this out. So I am left with sine square 2x du. Now that is problematic because I can only substitute u equals to sine x. So I then think about my identity for sine 2x and say that sine 2x should open up and become 2 sine x cos x. So then I see my substitution, but again that's only one of those. So let's first put the power and say that this becomes 4u squared into cos square x. Then I'm reminded that cos square x is 1 minus sine square x. So I get 4u squared 1 minus u squared. I open the bracket up because I can't integrate like that. It would have been wiser to take 4 out, but let's just get along with what we've done so far. And I have my limits. What are my limits? My limits should be 0 and pi over 2 as before. So I'm going to change the limits here. Sine of 0 is 0, so the bottom limit is 0, and sine pi over 2 1. So I think that's simple then. 4 over 3 minus 4 over 5 minus 0 over 3 minus 0 over 5. So 4 over 3 minus 4 over 5 should give us, I think, yes, we have the right answer. 8 over 15. Okay, moving on. Use the substitution u equals to sine 4x to find the exact value of this. So when I'm trying to solve this, I'm going to say that again I don't see any immediate substitutions. So what I'm going to do is I'm going to try to replace dx first and say that u equals to sine x, sine 4x. So du over dx is cos 4x into 4, and you get du over 4 cos 4x equals to dx. So du over 4 cos 4x. So what that helps me do is it helps me reduce this. I can pull out the 4 common, and this becomes power 2. Okay, so 1 over 4 comes outside, and I'm left with cos square 4x du. Now I can't go on and integrate x with du, so I'm going to say that this becomes 1 minus sine squared 4x, the simple identity that you learn in AS, and this becomes 1 minus u squared du. So that's a simple integration from there. U minus u cube over 3. I need to find my limits. The limits were 0 and pi over 24. Sine of 0 is 0, so 0. Sine of 4 pi over 24 is half. So I get half. So 1/4 half minus half cubed over 3 minus 0 minus 0. So 1 over 24, 1 divided by 2 minus 1 over 24 into 4 into 0.25. 11 over 96. Yes, that is indeed the correct answer. So that gets us to another question. Let's look at question number 5. It says, let I be this, using the substitution u equals to 2 minus root x. So let's see what I see, whatever substitution I can replace first, where I'm going to say that I've replaced that. So let's replace dx now. I never use my substitution, modify my substitution in the first step, in case I know I can, some of you might think that root x could easily be replaced, and I'm going to do that with time. There's nothing to worry about. There is more to this question, so we'll see that. Differentiating root x gives me minus half x power half minus 1. So I get minus 1 over 2 root x, and du over dx is here. So 2 root x with a minus is dx. Okay, so minus 2 root x over u. Now, what I wanted was for this to be replaced with u, but unfortunately there's a lot of multiplication right now happening, and now what I see is that I could replace root of x with 2 minus u. So let's do that. This becomes 2 minus u over u and minus 2 u du. And the proof that I see is 2 minus u whole squared. I made a silly mistake. Minus 2 is outside, 2 minus u du. Okay, so I have minus 2 minus u squared over u. I think I have most of the proof. The only problem is that I have a minus sign and they don't, and there's a reason for that. If you look at the limits now, if I start changing the limits, the lower limit was 0, so the lower limit is 2, and when I plug in the upper limit, which was 1, so 2 minus root of 1 gives me 1. So the upper limit is 1. Now if you notice, this difference between minus 2 and plus 2 is because of the inverted limits. My lower limit is the upper limit of the question, and my upper limit is the lower limit of the question. So what I'm going to do is, I know that there's a rule that says that if you want to invert the limits a to b of f of x, you can simply write it with a minus outside and say that this is b to a f of x. So I'm going to put a minus, an additional minus outside, and say that I want to invert the limits, and I'm going to keep the minus that was inside, and these two negative signs then come together to form a positive. So this becomes plus 1 over 2 minus u squared over u, and that proves my question. Then it says, hence show that when I integrate this, this shows that 8 ln 2 minus 5. Okay, the second part is integrating this, so I'm going to start again and then say that I can't integrate this with the denominator, so I'm going to have to separate the terms. But at the end of the day, I have to expand the numerator as well, because I don't think I can integrate it without expanding. Why don't I just pull out the 2 outside? That makes it easier. So I get 4 minus 4u plus u square in the numerator, and there's a u in the denominator for each of these terms. So I get 4 over u minus 4 plus u. So the integration of 4 over u is 4 ln u minus 4u plus u square over 2, and my limits are 1 to 2. So when I plug in the limit 2, it gives me 4 ln 2 minus 8 plus 4 over 2 minus 4 ln 1 is 0, 4 into 1 and half. So 4 ln 2 Hmm. I may have made a mistake somewhere, but no. Okay, that's fine. Minus 8 plus 2 minus 0 plus 4 minus half. So 4 ln 2 with the 2 outside, minus 6 and minus 2 and minus 2 and a half. So minus 2 and a half. That gives me 8 ln 2 minus 5. Is that the correct answer? Yes, that's what I was asked to prove. So that is correct. Moving on to the next question quickly. Question number 6 says the diagram shows the part of the curve y equals to sine cube 2x cos cube 2x. The shaded region shown is bounded by the curve in the x-axis and its exact area is denoted by a. Using the substitution u equals to sine 2x in a suitable integral to find the value of a. Okay, so let's start here. I'm going to use that suitable integral. I need the first um, x-intercept as well. So I'm going to say that this is sine cube 2x cos cube 2x equals to 0. So either this equals to 0 or that equals to 0. Now when is sine 2x equals to 0, it's in the first quadrant, and the second quadrant, let's just take the first quadrant because I want the first value. So I'm going to say that sine inverse of 0 is 0. So 2x equals to 0, x gives me 0. The next x will be pi, and I don't think pi over 2 should be the right answer, but let's check here. When is cos 2x equals to 0? Cos 2x is equals to 0 when I say cos inverse of 0. The calculator tells me that the answer is pi over 2, so 2x equals to pi over 2, so x is therefore equals to pi over 4. So my integral is 0 to pi over 4 of sine cube 2x cos cube 2x. My substitution is u equals to sine 2x. I'm going to do the immediate substitution first, u cube and cos cube 2x, and write the dx here. Don't forget the dx because then when you want to replace it, you're lost. Cos 2x into 2. So du over 2 cos 2x equals to dx squared. So I have u cube cos squared 2x du. Again, using the basic identity, I'm going to say that 1 minus sine squared 2x. So this gives me u cube minus 1 minus u squared. There's a half outside. So u cube minus u power 5. And I still have to integrate this. So this becomes u power 4 over 4 minus u power 6 over 6. With a half outside and the limits u equals to sine 2 into 0, that gives me 0, and sine 2 pi over 4 gives me 1, so 0 to 1. So I think the 0 is useless, so I'm just going to use 1 over 4 minus 1 over 6 and put that on a calculator. 1 divided by 4 minus 1 over 6 into 0.5. It gives me 1 over 24 as my final answer. I hope that's the correct answer. Yes, it is. Then part 2 is very interesting. Part 2 says given that 0 to k pi. Now notice that my limits right now were 0 to pi over 4. Okay, I want to find out when it would be k pi. The modulus of sine cube 2x. So now I'm talking about a curve that goes like this again. This negative side gets reflected to the positive side. Why? Because I'm putting a modulus there. So that's the area that I'm talking about, and it's 40 times a. 40 times a means that I found out the value of a, which was 1 over 24, and I can say that what I want the area to be is 40 times 1 over 24. which means that I want the area to be 40 into divided by 24. Okay, so I want the area to be 5 over 3. Okay, find the value of the constant k. So how long will I be required to go in order to reach that point? Remember that this point was pi over 4. So it took me a quarter of pi to reach a. I want to reach 40a. Okay, what I can simply do is I can make ratios out of it, and I can say that duration or time or whatever and area. So I reached pi over 4 was my duration, and I reached an area of 1 over 24. And now I don't know k, I don't know my duration k pi, and I want the area to be 5 over 3. I can simply cross multiply because it's going to be in proportion. The areas are getting added together. Okay, so cross multiplying this gives me 5 over 3 pi over 4 equals to k pi over 24. Pi and pi cancel out. 2 times 1, 2 times 12, 4 times 1, 4 times 3. I think I made a calculation mistake somewhere. Let me just check. This is 5 over 3. Oh, yeah, that was my calculation mistake. 3 times 1, 3 times 8, 4 times 1, 4 times 2. So 10 equals to k. Yeah, that is the correct answer. So it was just about having proportions in areas and then calculating forwards. Let's look at this area. It says the shaded region between the part of the curve this, where x is in radians. The shaded region between the curve, the axis, and the line x equals to p square, where p is greater than 0 is denoted by r. The area of r is equals to 1. Use the substitution this to find cos root of x, the area basically, and hence show that this. So I just need to integrate. Let's see what my immediate substitution is first. I get cos of root u squared, so that means my square will cancel out and I have dx. Okay, so x equals to u squared, dx over du is 2u, so dx is basically 2u du. So I have cos u and 2u du. So what I have ended up with is a question on integration by parts. You see an algebraic and you see a trigonometric with u as the variables. So I'm going to use isolate. I haven't changed the limits. We'll talk about the limits in a bit. In fact, we should just go ahead and change those limits as well. So x equals to u square when x is 0, u squared. U is also when x is 0, u should also be 0, so the lower limit is 0. And when x is p squared, u is u squared, so u should equal p. Okay, then I use isolate. I have algebraic and trigonometric. I'm going to say that my u is 2u. This is the u from the isolate formula, and v dash is cos of u, so v is sine of u, and u dash is 2. So vu minus integration of vu dash, vu sine u into 2u, 2 into cos u. No, sorry, sine u. So sine u gets integrated to minus cos u, and I have my limits 0 to p. Okay, and this area is basically, it says the area of r is equals to 1. So with limits, this is equals to 1. So I'm going to say 2p sine p plus 2 cos p minus 0 plus 2 cos of 0 equals to 1. So 2p sine p plus 2 cos p minus 2 equals to 1. Yeah, I have 3. That's what I'm getting as well. So 2p sine p plus 2 cos p equals to 3. So 2p sine p, 3 minus 2 cos p, 2p sine p. Sine p is equals to 3 minus 2 cos p over 2p. Moving on to the next question. Okay, this one says by differentiating 1 over cos x, show that the derivative of sec x is sec x plus tan x. Show that if y equals to this, then dy over dx is that. Okay. So if y equals to sec x, so y equals to 1 over cos x. Differentiating that would mean that I bring it up and have a negative power, and dy by dx would then be minus 1 cos x power minus 2 into the differential of cos x is minus sine x. So I have sine x over cos square x. I can break up the cos square x and say that one of these becomes tan x and the other one becomes sec x. So I have tan x into sec x. That is what the question was asking me to do. Then it says if, hence show that if y equals to ln this, y equals to ln sec x plus tan x, the differential would be sec x. So dy over dx is 1 over sec x plus tan x into the differential of the bracket. So remember that you just differentiated sec x as sec x tan x, and tan x itself differentiates to sec square x. So I'm differentiating this here because that's f bar of x. I can take a sec x common and then say that the numerator and denominator have something in common that cancels out. So I'm left with sec x. That was simple. Let's see using the substitution x equals to root 3 tan theta. Part 2. Find the exact value of this. So 1 over root 3 plus root 3 tan theta whole square. That's like quite a weird question. I have a dx here. Okay, so let's try doing that. There's a root inside the root. Let's see if that simplifies. So that's 3 plus 3 tan square theta. And replacing dx, so I have root 3 tan theta. So that gives me dx over d theta is root 3 sec square theta. And dx over dx equals to root 3 sec square theta d theta. Root 3 sec square theta d theta. Okay, then I can factor out a 3 and say that 1 plus tan square theta is basically sec square theta. So I sort of see the solution emerging. I also see root 3 can also sort of cancel out. So I don't need to be really worried about that. So I can separate this and say that this is separated into this, and 1 plus tan square theta is sec square theta. So the root cancels out, and I have 1 over sec theta. The root makes it lower down in power, and then one of these cancels out. Remember that so far I haven't integrated, I'm just doing the algebraic part. So I have sec theta d theta. Now this question is again about that part of the topic where that part of integration where we talk about integration being the reverse process of differentiation. So when it's the reverse process of differentiation, if you notice that the derivative of this is this, therefore and the derivative of this is that, So the integral of this should be that. Okay, so I'm going to say that sec theta integrates to ln sec theta plus tan theta. I don't know if I converted the limits earlier, but I can do them now. 1, 2, 3 were the limits, and they were the limits for x. So when x is 1, 1 over root 3, theta is what? Tan inverse of 1 over root 3. That's pi over 6. So the lower limit is pi over 6. And what's the upper limit? It's 3. So 3 equals to tan theta, root 3 tan theta. Tan theta equals to 3 over root 3 tan inverse of 3 over root 3. It's pi over 3. So let's apply the limits. Ln sec pi over 3 plus tan pi over 3 minus ln sec pi over 6 minus tan pi over 6. Do I have to give you expressing your answer as a single logarithm? So there's more to it. So this gives me 1 over cos pi over 3. Cos pi over 3 is basically half, so this should give me 2. And tan pi over 3 just came out to be 3 over root 3, which is basically just root 3. And sec pi over 6 is 2 over root 3. And tan pi over 6 is root 3 over 3. Okay. So at the end of the day, this is the single logarithm that I'm going to get. Ln of 2 plus root 3 divided by 2 over root 3 minus root 3 over 3. But I think it's wise to just simplify these fractions first. The second one is a little complicated, so let's put that on our calculators and see if it gives me an easier answer to work with. Root 3 over 3, I can also do it manually, but I'd rather not play with that right now and say that this becomes ln root 3 over 3, and this is ln 2 plus root 3. Okay, then it's just ln 2 plus root 3 divided by root 3 over 3. So that gives me ln 3 into 2 is 6 because I reversed the denominator. Okay, and then if I were to put that on a calculator, I think that would give me the correct answer. I seem to have made a mistake somewhere. Okay, there's a small mistake that I have made, and that sort of complicates things. Let's change that and see if we get the right answer. So 2 over root 3 plus root 3 over 3, that gives me root 3. So that's root 3. Yeah, that gives me the correct answer, surprisingly. Okay, so that is the end of this question. That is the end of this marathon. I will see you again with another marathon on integration by substitution. Please make sure to like, subscribe, and comment if you have other questions. Thank you.